So welcome everybody to the what's turned out to be about 4 or 5 times a year SCRT webinar on e-learning kind of topics that hopefully are advantageous to all of you. The Society of Cleaning and Restoration Technicians welcomes you as a member if you are not a member. So if you are a member, welcome. If you are not a member, welcome aboard. And this morning we have Kerry Mayeur speaking. He is with Phoenix Restoration Equipment Sales. I can't tell you, his resume is lengthy. I can tell you he's been with Phoenix for 16 years, I believe. And so I'm going to turn this over to Kerry. He can tell you whatever he wants to tell you. And I'm going to stop the sharing, Kerry, so you can go ahead.
All right. Well, since the webinar has already started, I'll go past this screen. Let's see. I'm trying to advance my. Oh no. Let me. Wouldn't you know it? I can't advance my screen. All right. Let me. Just give me a second, Dick. Let me stop sharing.
Yep.
Share again. Let's try this.
There we go.
Here we go. All right, it's working. Yay. All right. So, well, thank you, Dick, for the introduction. Just a little bit about myself. Like Dick said, my name is Kerry Mayeur. I work for Phoenix Restoration Equipment. My official title is Sales and Technical Training. My email address and as my cell phone number. So I would invite everyone who is on the web, who was on the webinar, especially Brandon, to put me on your phone if you have any questions about anything, whether it's for equipment or setup or service or anything related like that. Please reach out to me. So my history a little bit, born and raised in New Orleans, stayed there 42 years, all the way up until Hurricane Katrina. Right after Katrina, I went up to Madison, Wisconsin, and that's when I started with Phoenix. Prior to that, I had 8 years of construction back in the 80s and 16 years of automotive from 1990 to 2005. And that brought me to Phoenix, like Dick said, 16 years with industry sales and technical support. So let's just, we'll jump right into it. And this is the agenda. So we're going to take a look at, let me see if we're going to take a look at how a refrigerant dehumidifier works. We'll take a look at how a desiccant dehumidifier works, when to use an LGR, when to use a desiccant, and we'll wrap it up with questions. This is not going to take long. I would assume it's going to take maybe 10 to 15 minutes to get through everything. So, so first, let's just jump into refrigerant dehumidifiers. So there's two different kinds. There's LGR and there is conventional. A conventional dehumidifier is a refrigerant dehumidifier that utilizes a refrigerant system to remove energy or heat from the air at the evaporator coil. This is cooling the air. This energy or the heat is returned to the air at the condenser coil, and that's heating the air. And basically, this is a balanced system, energy in, energy out. So a conventional dehumidifier quickly works down to about 55 GPP. The reason for this is that with a conventional dehumidifier, the evaporator can only get so cold. If the dew point is below the surface of the evaporator, then you get 0 grain depression, or you don't get any water in the bucket. And the rate, if anybody wants to know the way a refrigerant system works, there's 3 major components: a compressor, an evaporator, and a condenser. The compressor pulls Freon from the evaporator, and that's pulling out heat off the evaporator, which came from air. That air or that Freon is then compressed, and then put into the condenser where it can cool off. So if the refrigerant is cold or cool, then it could go back to the evaporator and absorb more heat. So that's a conventional DU. And you can think about this as a air conditioner with one airstream. So in your car or in your house, your air conditioner has two. You have one airstream across the evaporator coil, and you have one airstream across the condenser. In a dehumidifier, that's combined all into one. You have a single airstream. So conventional dehumidifiers compared to LGRs work quite differently. Now this setup, if you look down at the right-hand side of your screen, this is a typical LGR setup. So an LGR, or a low-grain refrigerant dehumidifier, has an enhanced airflow that pre-cools the incoming air. This allows the surface of the evaporator to achieve a much lower dew point than a conventional refrigerant dehumidifier. And that's because the evaporator in an LGR can get much, much colder. Now, because LGRs achieve a lower dew point, they have the ability to remove up to twice the water compared to a conventional refrigerant DU. So since 1994, when Phoenix was started, we have never had anything other than LGRs. We kind of stumbled upon that by accident with our residential units. But nonetheless, it works. So you have the air that comes in to the dehumidifier, it goes across a filter, keep a filter in it. You don't want to run these without one. It'll go through this thing called a heat exchanger. The heat exchanger is made out of coroplast, or plastic cardboard. And it's a bunch of plates that are stacked up on top of each other, and the air can pass through. When an air does pass through, then it goes to the evaporator, and this is where the air starts to cool off. So that cold air makes a U-turn and goes back through the heat exchanger, pre-cooling that incoming air. Now, keep in mind, these two air streams do not touch. The heat transfer is through the plastic. Now, because you have the cold air pre-cooling the incoming air that's going back across the evaporator, now the evaporator can get much, much colder because of that pre-cooler. And then once the air goes through the heat exchanger the second time, then it'll go across the condenser. It'll cool off the condenser or warm up air. And that's basically cooling off the freon within the condenser so that can go back around through the evaporator to absorb more. Now, because you use a heat exchanger or some type of pre-cooling to allow that dew point to be much, much lower, LGRs can work down to somewhere around 30 to 35 grains, depending on the amount of moisture in the air. So from there, we'll go into how a desiccant works. Now, a desiccant dehumidifier works quite differently than a refrigerant, as you can see in the diagram below. It has no compressor, it has no condenser, no evaporator. In fact, the desiccant dehumidifier has much fewer parts than a refrigerant DU. So what happens is the air is pulled in across the rotor, and first it goes through a filter, and that's number 2 down there. And again, you really do want to make sure that you keep filters in these things. Any dirt that's in the air will land on a rotor and stay there. And if it does, it'll impede the airflow, and then things just don't work as they should. Anyway, the air is pulled in across the rotor, and this is called process in. And this is where the moisture is absorbed by the silica gel. Silica gel is what the rotor is made out of. So after the air exits the rotor, that air is now dry, which is called process out. This is the air that you want to use in the room or in containment or whatever it is that you're trying to dry. Now, the silica gel needs to be dried in order for it to absorb more moisture. Now, think about the rotor as a sponge. If you took a sponge and you dipped it in a bucket of water and you pull that sponge out, if you did not wring it out, then you can't hope to absorb more water if you put it back into that bucket. So you have to wring it out so that when you do put it back in the water, you absorb more moisture. Same thing with the silica gel rotor. It will eventually, if you don't reactivate it, it will eventually get saturated. Once it does, it can absorb more. So what we do is we need heat to break the bond between silica gel and a water molecule. So the way we do that is we pull air into a separate airstream. Now, I'll say separate because this is an example of a 4-hole desiccant dehumidifier. There are 3-hole dehumidifiers commonly known per system. We could talk about that a little bit afterwards, but in this demonstration, just to learn a little bit how they work, we'll just use the 4-hole. So the air is pulled in by a separate airstream. It's heated up and it passes through a segregated section of the rotor. Remember, the rotor by its name does rotate, and that's called reactivation in. Now, once the air and the water vapor exits the opposite side, it's going to be really wet. This air is going to be super wet. It's called reactivation out, and that has to be ducted outside of the structure in which you're trying to dry. So always tell this to everyone that if there is anything, if there's the most important thing you have to remember about a refrigerant, kind of like there's one thing you have to remember about a desiccant dehumidifier, a lot like a refrigerant. You have to get rid of the wet air and a refrigerant, the water. So you can forget everything else, but just remember, take the wet air and duct it outside. So on the bottom, if you see a little bit of a diagram, again, the air goes in, processed through the filter, then goes through the rotor. That air is now dry. It goes back out into the structure, which you're trying to dry. It's called process out. And then you have the reactivation inlet, goes through a filter, goes through a heater, goes across the rotor. It bakes, for the lack of a better term, the water off of the rotor. And then it goes out, hopefully outside into the atmosphere. So let's talk about when to use LGRs and compare to the desiccants. We'll get that in the next slide. These LGRs are typically used on class 1, 2, and 3. So in a class 1 water loss, it may only affect part of a room or an area. They may include a larger area of materials that have absorbed a minimum amount of moisture, least amount of water absorption and evaporation. So in a class 2 water loss, it affects at least the entire room of carpet and cushion, and the water has gone up the walls or wicked up the walls less than about 24 inches. And there's moisture remaining in the structural materials like plywood, particle board, structural wood, VCT, and concrete. And this is considered a large amount of water. Now in a class 3 water, I'm sorry about that. In a class 3 water loss, this typically came from overhead. In a class 3, the ceilings, the walls, carpet, insulation, subfloors, everything is saturated water from above, and this is considered the most amount of water. And these are the 3 cases that you would typically use LGRs. And the reason is because all of the structures, whether it's drywall, studs, carpet, pad, subfloor, things are typically easy to dry. That's why you would use LGRs, because LGRs are much more efficient than a desiccant. But there are times that you would want to use a desiccant, and that's considered class 4 or specialty drying. So class 4 water loss includes wet materials with very low permeance porosity, such as hardwood, plaster, brick, concrete, lightweight concrete, and stone. These materials require very low specific humidity and vapor pressure in order for that moisture to come out of that material. So class 4 water loss typically requires longer drying times and special methods such as containment. And what by that, if let's say you have a wood floor and you want to dry and you want to try to keep up with the rate of drying that everything else is being dried with a refrigerant, you want to target the dry air, that low vapor pressure air over the materials that you want to dry, and you would do this with containment or perhaps polyethylene sheeting over a floor. Desiccant dehumidifiers are also widely used in temperatures that are unfavorable for LGRs. LGRs work really well between 90 degrees. There are some LGRs that work better, more or higher than 90 degrees, but very, very few of them can work efficiently below 70. And that's because below 70 degrees, the evaporator gets so cold, it just keeps going in and out of defrost. So when you have temperature sensitive areas or crawl spaces, or it's just too doggone cold in the structure, maybe you don't have the ability to add some energy to bring the temperature up, this is when you would want to use desiccant dehumidifiers. And also desiccant dehumidifiers are widely used in large loss or commercial drying. And these are typically used to dry structures with multiple rooms, such as hotels and office buildings. The reason that is, imagine a hotel that had the roof blew off and every room in the entire hotel is wet. That means a contractor, and most hotels or even office spaces are separated by doors and walls and everything else. So a contractor would have to go in and put hundreds of dehumidifiers in order to dry that structure. A contractor would typically bring a Desiccant demier, a large one, somewhere around 5,000 CFM or bigger, and they would run one single line from that dehumidifier onto multiple floors with ducting into each room to dry those areas. So it's in a large loss or commercial drying, using Desiccants are more efficient than using LGRs.
Kerry, could I ask
And
a
I believe,
question?
yes, sir.
Is there a way, and we can take this off table, but is there a way to determine how big of a desiccant you need? Is there a
There
formula?
is. It's all about, yes. Yeah. So it's all about air changes. So when you size air changes, when you size a job with desiccants, you have to figure out the cubic feet. And if you know the cubic, the CFM of the desiccant, then you can figure out how many air changes you're going to get within an hour. There's different ones, Rocky. There's a minimum amount of air changes. I think the minimum is probably 1, and it goes all the way up to 4. So if you have something like a hotel that's really wet, you're probably going to have to do 4 air changes an hour. And then you use some division with the CFM of the desiccant to determine how many air changes you can from that piece of equipment.
Gotcha.
All right.
Kerry, do you have a like a cheat sheet or a card that has the formula on it in order to calculate length and width and height to arrive at cubic and then divided by the CFM and so forth?
Yeah, we do. We used to have that in our catalog. We took it out because there were some changes in the IICRC standards. But I can get that, and I would be more than happy to share that with anyone. You could send out a text or an email to me and just say, hey, send me sizing charts, and I'll be more than happy to send those over.
Okay.
And I believe they may be, or they used to be on our website. And if they're not, I could get those back up onto our website so that it'd be a nice, just a resource to use to size jobs.
Another question, many of the contractors that I talk with in the winter time are doing whole house dry downs, and they're doing a whole house because it froze and broke as the heating system is down, and sometimes the heating system is underwater or doesn't work. Right. And so in that scenario, it sounds like a desiccant is appropriate, but maybe not a 5,000 CFM desiccant.
Yes, that's correct. So certainly desiccant is going to be more appropriate in a structure that does not have heat when the temperatures are below 70. Now, keep in mind, here up in Ohio, it gets quite cold winter. So if the roof of my house blew off and then it rained and it got saturated, and that night it froze, everything is frozen inside the house because there's no heat. And remember, you have something where your roof blew off and the entire house is saturated, more than likely the power is going to be off. So you have no means to heat it up, unless you're going to bring in some simple supplemental heat. So in that case, you would use a desiccant. But keep in mind, even though a desiccant can get the vapor pressure very, very low in the air, keep in mind you still have to get that water in those materials into the air. So if the entire house is frozen, that's a little bit of a difficult task, but you can bring in temporary heat to at least bring the temperature up in the structure to create some evaporation so that the desiccant can remove the moisture from the air. Now it is funny, LGRs, they work really well between 70 and 90 degrees. Desiccants actually work best when the air is somewhere around 50. And that's because the rotor itself is cool enough or stays cool enough so they can absorb the maximum amount of water.
Kerry, can you tell us how many what the differences are? Phoenix makes some desiccants, obviously. What are the different CFM sizes? Yeah.
So the ones that we sell, we have one, it's called a 385. That's 385 CFM. And that's relatively small in comparison to the other ones that are on the market. We also make one that's called a D850. It is 850 CFM. And that's where you're going to get into larger residential, smaller commercial jobs. And finally, we make one that's 4,800 CFM. That's when you get into the very large loss stuff. And we don't make any, but there are some out there that go up to, I mean, over 15,000 CFM. And that's some really, really big, for some really big buildings.
Great. That's all my questions.
All right. Anybody else have any questions? All right. Well, Dick, that's all I have. And I do appreciate you guys having me. And anytime you would like me to come on and do this again, I would love to.
Kerry, I appreciate you taking the time to do this. It didn't go as long as some of our presentations, but the information is extremely valuable. Even if you've been in the business a long time. I don't do drying anymore. I just do consulting, but I talk to a lot of contractors that don't know this information. So with your permission, I have recorded it, and I'm going to convert that link to a YouTube and send it out to a number of contractors.
Yeah, please do.
Is
Absolutely.
Is
And
anybody?
if you can, yeah, and if you can keep my information on there, like I said, anybody who wants to call, I'll be more than happy to help them.
We do weekly training. Dick, if you wouldn't mind sending that to me, I'd love to play this video for my my water techs.
Yes, I will send it to you, Rocky.
Yeah, it was very helpful, Kerry.
All right, thanks, Rocky.
I'll be the hag that nags to get that calculation link.
Yeah.
Okay, yeah, I will definitely do that. All right.
If you can,
All right, thank you, guys.
thank you, Kerry. If you can unshare your screen,
All right.
and then I will share it. Try to find it, share, and of course, doesn't work this time. But anyway, if my information or Kerry's was on the screen, you can send Kerry a text and he will send you that info. Thank you, everybody, for watching. See you next time. Thank you. Bye-bye.
Bye.
Thank you.